Okay. Hello, everyone. I'm Karan Gupta, Manager Software Engineering at Arista Networks. And in this section, we'll take a deep dive into the technology behind Arista's Cognitive Wi-Fi solution. So before we get into the details, right, let's understand the different dimensions of a client experience in a Wi-Fi network. So we start with connectivity, performance, and then we go to the app experience. And as we go from the bottom of the pyramid to the top of the pyramid, the understanding of the client experience becomes less and less deterministic. And in this first section, I'm going to mainly talk about performance, right? We looked at the client journey, which takes care of connectivity. And in terms of performance, I'll talk about automated root cause analysis. Now, why do we need automated root cause analysis, right? So let's say your client is facing some issue with the network. Now, there are two types of issues that it can mainly face. One is connectivity issues, and the other is performance issues. And in connectivity issues, you can essentially monitor the AP state machine to understand what's going on when the client is trying to connect, and that gives you something that we call the client journey, where you are able to understand, where the client is dropping off, association, or network, and so on. But what about performance issues? It's not that straightforward. It's not like you can monitor any state machine anywhere. It's much more nuanced. And that's where automated root cause analysis comes in. Now let's see how Ava does this. So we built our automated root cause analysis into Ava. The first step here is really looking at the symptom. What is the client facing? What's the issue that the client is facing? So it can be low data rate, for example. Then you look at the observations. You essentially understand what are the other clients in the network and what are their properties. You also look at the domain knowledge. Now, this is something that you know about Wi-Fi, what parameters in Wi-Fi are related to the other parameters. And you look at the system knowledge, which is, the configuration setting, what is your SSID setting, and things like that. And once you have all that input, Ava generates the RCA, and it gives you the root causes, what is responsible for, this symptom, let's say low data rate. And it also gives you some recommendations, actionable things that you can do, like, for example, turning on auto transmit power. And it supports that with an evidence, right? So it doesn't leave you just with its own opinion. It gives you the evidence why it thinks what it thinks. So we'll look at each of these things in detail. So let's look at observations. So Ava can actually do two types of root cause analysis. One is the network level root cause analysis, and other is the single client root cause analysis. In network level root cause analysis, you are essentially looking at the entire network and trying to understand what's wrong with the network, or specific parts of the network and with the client experience. With a single client RCA, you essentially are looking at a specific client and trying to troubleshoot that client. And when you are doing network level analysis, you are looking at essentially all the clients in the network and trying to see what their Wi-Fi parameters are. Like, are they facing low RSI? Are they facing high data rate, and so on, right? And what you're trying to determine is why is there low data rate in the network for some clients. So that's your observation. Now, if we move on, let's talk about the domain knowledge. Now, this is something that all of you are aware of, and this is not an exhaustive diagram, but it gives you an idea, right? So you know that when a client is facing poor app experience, that can be due to low data rate, high data rate, or high contention, which in turn can be due to low RSI and other factors, right? So this is a domain knowledge that's built into Ava, and that's something that a Wi-Fi expert also knows. Moving on to system knowledge. Now, this is what is the state of the Wi-Fi system, right? What are the things that are on and off in the network, right? Is auto transmit power on? Is dynamic channel selection on? Is 5 gigahertz being used, right? Essentially understanding how the network is configured. So those are the parameters on the network side. There can be other meta parameters, such as, how your location tree is configured, and, what is your list of APs and what are their properties, right? So you can look at this entire system knowledge to understand what's going on. Now, moving on to symptom. Now, what's a symptom? It's important to understand. So a symptom is any external manifestation of failure. So it is essentially something that you can observe, right? So let's say you're having a fever. Now, that's an external thing that you can measure. And in case of Wi-Fi, you can think of two high-level symptoms. One is that the client is getting poor app experience, which we'll talk more about later. And the other can be, low data rate. The client is not getting the data rate that's expected. And an RCA engine like Ava is supposed to actually look at the observations and then infer which of the many root causes are responsible for one of these symptoms, right? So we'll move to root causes from here. Now, root causes are events that can cause other events, but are not necessarily but are not themselves caused by other events. So these are things that can cause a symptom. For example, poor coverage can cause low data rate, right? And so on. So these are the on the edge that you see, going back to the dependency graph. These are the root causes that can potentially cause low data rate or poor app experience, right? So in case like if you have a fever, then it can, you probably have a viral fever, or it can also be that you are exhausted, right? So that's really the root cause. We don't stop there. So you also can consider location, vendor, OS, access point, these things as root causes, though they are not root causes in the real sense of the term, but these can give you interesting insights. Is a specific access point causing more issues, or is a specific type of device causing more issues, or a specific location, right? So you can sort of consider them as something that can give you some insights into how to debug and troubleshoot. Now, once you have the root cause, the next step really is the recommendations, right? These are the actions that the system can suggest that you can take to mitigate the issue. And in this case, we can see that, for each of these root causes, there can be certain actions that the system can recommend. And what we do is, what Ava does is it's not making recommendations blindly. It's actually looking into your system configuration that we saw earlier, and then giving you the recommendation, right? So if client is facing poor coverage, then it would recommend increasing transmit power only if it's not at the highest level, or it would recommend enabling client steering only if it is not enabled, right? So it's going to make recommendations only if you have not already followed those things. So it's going to look into the configuration as well. Now, how do we do this? So we use machine learning for root cause analysis, and this is a very one of the ways in which we do it. So you take the data, that is a list of all the clients, and you train a decision tree model. Essentially, what that gives you is a decision tree, which is very human interpretable. And from there, instead of asking the tree, in typical machine learning, you will ask to predict, you would actually read the tree itself to understand and generate the RCA statement. So for example, in this case, if you read the tree, it's trying to say that if the client is operating in 2.4 gigahertz and there is high retry rate, then it's more likely to get low data rate or poor application experience. Now let's look at Ava's RCA in action.
I have a question in the meantime, Karan.
Sure. Yeah.
Whenever you find the root cause analysis or the root cause issue, and then you come up with different recommendations, do you guys do any tracking after the recommendation has been applied to the system to do some sort of reinforcement learning and learn from these changes to make sure that it fixed the user experience on that?
No, that's a good question. So that's something that we don't do today, right? But you can actually track that using the baseline. So there is no automated way to do it right now, but that's the loop that we want to close eventually.
Okay, thank you.
Yeah.
Is there any disambiguation under authentication there? For example, ADA21X, the PSK, the failed to open for some reason?
Yeah, so is your question that, for connectivity issue, do we get into the details and tell you exactly what happened?
Yeah, like say if we clicked on the red number there, would it show us a breakdown of why each failed under authentication, or as near as it can get?
Yeah, it actually gets into the details. So this demo is actually from one of our large customers. So it's actually from their network. Let me start this. So we'll go directly to the performance dashboard because that's our focus. And we ask Ava to do root cause analysis on these clients that are affected. You can see in the client health, we have certain clients that are affected due to various reasons. And it's actually looking at all the clients, and it says that it has found root causes for certain number of clients. And here you'll see that, we have a number of top locations that are affected. And it also tells you about which of these, it also tells you about which of these, root causes are responsible across these different locations. So you can see that, there are list of clients that are listed that, these many clients are affected and at this location, and what are the top root causes across various locations. So you'll see that there is a 2.4 gigahertz only network, there is high contention, high Wi-Fi interference, right? So from here on, what you can really do is you can click on one location and drill down to see the individual root cause analysis statements. And along with each statement, it also shows you the list of clients that are impacted due to that root cause. So here we see high Wi-Fi interference. And if you want to see all the other root cause statements that is generated across all the locations, you can just scroll through them and understand what's going on. And you'll see that there is a rich set of root causes that the Ava engine has come up with. And in this case, we'll essentially look at one of these statements. So let's look at this one. And you'll see that, these 6 clients are at a specific location are impacted by high contention and slow, and they are essentially slow BG only clients. And once you click on the light bulb, it'll give you the recommendation. So here you'll see that it's telling you very specifically that, you need to set the transmit power selection to auto and enable dynamic channel selection at that specific location, right? So to ensure that, you are running an optimum network. If you look at the other statement, it essentially gives you a simple recommendation that, it's better to use dual band capable clients for better performance. They are going to bring down the rest of the network as well, right? So from there on, you can actually look at other statements as well, right? You can just scroll through and see what are the other statements that have been generated. And the idea here is not to give you, the exact reason. The idea here is to reduce the time that it takes for you to troubleshoot by understanding what's going on in the network. So you have, as you saw in the slide, right, you have this wide range of root causes that are possible. Now, Ava actually helps you narrow that down to a few root causes that you can investigate and, take actions on. And it also recommends what you can really do by looking into your system configuration.
So is that decision tree actually like built into the system? Is that something that's available for us to look at and see how it's come to that decision?
Yeah, so what you're looking at is actually statements generated from the decision tree, right? So you are essentially looking at that tree in a different format, right? So if you say high contention and, let's say slow clients, then that's actually reading a path in the decision tree. So we don't represent the tree as it is, but we make it more consumable as statements. And with each statement, we also club a list of clients at the bottom so that you can see which clients are actually impacted. So that's the evidence part that I was talking about, right?
Do you have different level of priorities depending on what the problem is?
So
what I mean?
So what we do is that we indicate to you, if I go back a bit, we indicate to you how many clients are affected, right, with that root cause. So that sort of indicates what is the impact radius of that issue, right? So with each statement, we have that, right? So you can actually start from the top and with in each location, how many clients are affected. So that's sort of indicates to you what's the impact of that issue.
Thank you.
When you say clients are experiencing low RSSI, I take it you mean that the access points are hearing the clients at a low RSSI.
Right.
And if that's a root cause, are you flagging that just because you can hear a client at a low RSSI, or are you saying that we've detected some problem which we're saying this is the cause of, or is it just that the client has a low RSSI?
Yeah, so you would typically start with a higher level symptom, right? For example, you will start with low data rate and then try to understand is low RSI the issue, right? Now, low RSI can be due to two things. One is poor coverage, or the client is sticky. It's simply refusing to connect to a better access point. So we actually distinguish between the two when we are doing root cause analysis, right? So it depends on where you're starting off. What is your symptom? So the highest level symptoms you would typically start off is low data rate or poor app experience. That's what you really care about, right? So if you're using a device which is getting a decent data rate, even with low RSI, you don't care about that much.
It depends a little bit what the client is doing as well, though, isn't it? There might be a client operating at a low RSSI with a low data rate, but the early need for that client, that's absolutely fine because they're not actually doing much in terms of data throughput, or they're doing a bit of barcode scanning, or they're doing something like that,
right.
And therefore it's not a problem.
That's correct. So that's why we have this focus on application quality of experience, right? So that's why I keep mentioning that. You're correct that there might be IoT devices that are actually happy or actually are transmitting at low data rate. That's what they really need, right? Mm. So that's the next section where we'll talk about application quality of experience. That's really the highest level at which you want to measure the client experience, right? So
okay, great.
Yeah.
I look forward to the next bit.
Yeah. Now coming back to client experience. So what we saw was how you can use root cause analysis to take care of connectivity performance. But the next step here really is, and the least deterministic bit, is understanding the application quality of experience, right? So when your clients are accessing your network, they understand, your users, they understand whether they are getting a good experience or not. But the key question is, can your network understand whether they are getting a good experience or not, right? And I think that was a really good question, right? Just having low data rate does not mean it's bad experience, right? So we tackled that question and innovated in that area back in 2018 by introducing Application QoE for conferencing applications. And what we did there, this is as a recap, is we detected if a call is going on. And for every 30 seconds of the call, we extracted some network level parameters. Now, going to privacy, all calls are encrypted, like Zoom and any calls that you make these days, they're encrypted. You cannot get access to the application data, but you do have access to the network layer parameters. So you extract those, you send that to the Arista cloud, and there you have these pre-trained models which classify this 30-second segment as good or bad. And you use that, and then you show that on the dashboard as application quality of experience for conferencing applications. So you say what percentage of time the call, the application experience was not good, and how many clients are affected. Now for us, the natural next step was to actually extend that to web applications, right? So we got into that, and we did a lot of web traffic analysis of, commonly used applications such as Google Drive and Office 365 and so on. And that led to a lot of TCP analysis. Most of the traffic on the web is TCP, and which led to not a surprising conclusion that, packet retransmissions are highly correlated with bad app experience. So we took all that knowledge, our data science team took all that knowledge and built that into Ava, which essentially, automatically detects packet retransmission events in these web applications. And then the model automatically computes or predicts the wait time due to packet loss. So this is what we call the recovery time, right? So it's the time that the flow or the application loses because of the packet loss, right? So TCP is a protocol which would actually retry if, there are packet losses. So that's the thing that we compute. Now, if you look at...
Can I just add something? So you're looking at TCP retransmissions, not wireless transmissions at that point. Is that correct?
Yes.
And do you ever correlate the two? So look at it, are the TCP retransmissions being caused by wireless retransmissions, or are they purely on the application side?
Right. So what we do is, once we detect that there is an issue, right, at a TCP level, right, from there you actually run the root cause analysis, and it will figure out whether high retry rate is one of the issues, right?
Okay.
And I'm unfamiliar with Arista's SD-WAN portfolio. Does this happen at the edge, like where you're touching the internet, or does this happen on core distribution in addition to Wi-Fi? How deep can you go into that flow?
Yeah, so this is happening on the access point. So I have a architecture slide after this, so I can clarify there where exactly we are doing this analysis, right? So just to quickly go through this one. So what we are doing is that each application that you're running, any web application that you're running, it will typically initiate multiple flows, right? And for each flow, we are essentially computing what is the recovery time for that flow. And at the application level, we essentially collate that information and also detect what is the idle time, which is the time that the application was not really being used. And we also then calculate the recovery time across all the flows. And once we have this information, we can use this to understand, what is the application experience. And this flow level analysis is actually being done on the access point itself. And our algorithm is efficient enough that it, just costs us like not more than 3% throughput overall. Now let's move to the architecture. How is this whole thing structured? So if you look at the access point, we have this Ava engine embedded on the access point. And the first thing it does is it detects the app, what type of app you're running. And from there on, it computes the recovery time and the idle time that we just saw for that application. And it sends that to the NetDB in the cloud. And eventually, we just aggregate that information and show that as percentage poor app experience for different applications, right? And I think the best way to see this would be as a demo. So let me quickly switch to that.
I was going to ask you, is this done like real time? Like how long does it take for the cloud to kind of analyze everything?
Yeah, this is all real time. So the actual engine is sitting on the access point, right? And it's just sending you the final data that, what is the recovery time and the idle time. So as your applications are being used, they are constantly being monitored.
For each client connected to the AP?
Yes.
Okay.
And if you have a cloud account, we support monitoring up to 25 applications simultaneously. So let me quickly run through this demo. So what we did was in the test setup, we had two clients, and one was operating in 2.4 gigahertz and one was operating in 5 gigahertz. And in our test setup, the 2.4 gigahertz is really crowded and 5 gigahertz is fairly available. So we essentially made both of these clients use certain applications. So you can see that, on the dashboard, we have certain applications that are being used, and you can also see the relative application quality of experience. Now, you can add multiple applications. We support about 1,600 applications that you can add. And that's not it. You can actually add custom applications. Essentially, if you have any internal applications, you can use this tool to also monitor them, right? Now, if you move on, right? So here we actually are showing only 5 applications, but you can monitor many more applications and see all of them in this dialog. And so let's investigate, let's see what's going on. So we see that, Evernote is not having a great experience. The clients are not having a great experience. And on the baseline also, you can see certain anomalies that are being pointed out. So most of the time things are sort of fine, but here we have some anomalies. And at the chart at the bottom, it shows you which clients are facing what percentage of poor application experience across all applications. We see a red bar there, and there is one client which is essentially not getting a great experience. And we drill down into that. And this is essentially running on 2.4 gigahertz. This client is connected to that SSID. And we drill down and try to see what's going on. So Ava tells you that this poor application experience is because of high contention BSIDs. Essentially, there are too many BSSIDs on that channel. And once you look at the recommendation, it tells you that you need to enable dynamic channel selection at that location. And that's not enough. You also get a list of contending APs at that location, so you can exactly see what's going on, right? So, so the point here is that if I quickly go back, so the point here is that what Arista's cognitive Wi-Fi solution does is that it not only helps you measure the quality of experience that the client is getting across this entire pyramid, right? It also tells you why that experience is not great and what you can do to make that experience great, what you can do to mitigate that issue. And that's what we really call cognitive Wi-Fi. So that's it from my side. Any questions?
Yeah, I guess I've got a question. I think the fact that you monitor the applications on the sort of wired side of the AP is really good, because often it's good to be able to try and answer the question whether it's like, is it an application and if it's a sort of RF problem. I'm just wondering if you do any sort of correlation between application performance and things like power save mechanisms on clients. Because I've seen a lot of times when you get in things like TCP retries, they're actually related to things like power save behavior on clients not receiving the packets, so they can't acknowledge them as a TCP level.
Mm-hmm. So yeah, we don't do that, but that's an interesting input. So we can actually, that would be one of the root causes, right? So we don't. So our Ava root cause analysis engine does not look into that today, but that's something that we can work on. So I think the point is that the engine is generic, and you can add more root causes to it. And what I showed was not an exhaustive list of root causes that we analyze, right? So we continue to add more and more root causes to that.
Also, as a quick note, in addition to what Peter said, I mean, TW2 with AX has a similar effect as well. The AB could be scheduling, clients for a very longer sleep time, and that may affect your, your TCP retransmission rate. Like, does the Ava take that into account as well?
Yeah. So, see, I would put it this way, right? Like, if the client is initiating certain traffic. So when you're talking about web applications or TCP applications, right, it would typically be the client which is initiating that traffic. So if it's already in the sleep mode, then, you are essentially talking about the idle time, right? So we actually distinguish between the idle time of the application and the actual time that the application is being used, right, before we arrive at the conclusion. So that's the key point that we need to also remember here.
Thank you.